In this video we solve problem 10 of unit 12. In it we want to build a parallel plane capacitor to meet certain characteristics. So we want to know what the difference between the plates should be and what the area of the plates should be. So let's imagine that this is the positively charged plate, the upper part, and the other is the negatively charged plate. We know that from points A to points V, this is the potential drop. We normally talk about directly V, and the maximum V that we're going to allow this capacitor to have is 2000 volts. On the other hand, we want we know that inside we're going to get a dielectric of kappa 24, and that can resist electric fields up to 4 times 10 to the 7 volt per meter. This is if the electric field between the plates is bigger than this, the dielectric will have a breakdown and will become a conductor. So we want the electric field to be at maximum this value here. So we know for A we want to know what the distance between plates should be. So we know there is a relationship between the maximum, the potential drop and the electric field across the plate, which is given by this, because we are in a parallel plane capacitor. So here you can see that provided a certain potential drop, if the distance between plates is very, very small, then the electric field is going to be very big. So this is going to set a minimum distance, and this minimum distance is going to be exactly the ratio between the maximum potential drop we're going to allow and the maximum electric field that the dielectric can handle. This minimum distance is going to be 2000 volts divided by 4 times 10 to the 7 volts per meter. And this, if you do the math, is 5 times 10 to the minus 5 meters. So this is the distance between plates, okay? Once we have the distance between plates, we can play to see if we can discover what the surface of the plates should be, okay? So we know that a capacitor, the capacitance of the capacitor is equal to epsilon sub 0 times kappa, because there is a dielectric inside, times A divided by D. And we know that the capacitance we wanted to have is 0.1 microfarad. So here we just have to solve for A, because we have already set what the distance between plates should be. So we just have to solve for A. If we do so, then A has to be the capacitance times D divided by epsilon sub 0 kappa. If you do the maths, this provides 0.0235 square meters for the plates.